Welcome back. Today I will be talking about how to find E and Z configurations of alkenes in organic chemistry. Now it's likely that you are already familiar with cis and trans molecules. Right, so the one on the left here is cis, and I'll draw the implied hydrogens. Cis tells us that the most important groups, the heavier groups, the methyls, are on the same side if we divide the molecule horizontally. And trans over here, if we divide this as such, parallel to the double bond, we see that the most important groups, these methyls, are on opposite sides. However, we meet challenges when we look at molecules such as these, and we try to figure out whether they are cis and trans. Turns out, because there are more than two groups here on these molecules, we cannot designate cis and trans. Instead, we use the E and Z system. The way this works is that we're going to assign priorities. So we're going to split the molecule in half, put a little dotted line perpendicular to the double bond, and then on each side we will decide who's priority 1 and who's priority number 2 on each side. Priorities will be decided much like we decided priorities for RNS configuration. After the priorities have been assigned, we'll draw this yellow horizontal line and see where the priorities lie. If they're on the same side of the yellow line, then that will be Z configuration. If they are on opposite sides of the dotted yellow line, it will be an E configuration. Now E and Z, those come from two German words. E is for entgegen, which means opposite sides, and Z stands for zusammen, which essentially tells us same side. To put this into practice, let's assign E or Z to this molecule on the left. So first we will assign priorities on each side of the blue line. Looking at the left side, we're going to take the bigger element, so the one with the greater atomic number or atomic weight. It turns out that bromine is heavier, so priority number 1 will go to the bromine, and priority number 2 will go to the chlorine. So bromine is more important or heavier than chlorine. Then we will go to the other side, the right side of the blue line, and we will decide whether iodine or fluorine is the priority. Turns out iodine with a higher atomic number is going to be priority number 1 on this side, and fluorine will be priority number 2. Now let's look at this yellow line and see where the priorities lie. We see that priority number 1 lies on this side of the yellow line, and priority number 1 on the other side is going to lie on this side. So because these priorities lie on opposite sides of the yellow line, right, so this alkene, just meaning a compound with a double bond, is going to be E configuration. Now let's practice this again. So on the molecule on the right, we're going to decide priorities on each side of this double bond. Right, so let's do the left first. The question here is whether fluorine or oxygen is higher priority. Fluorine has a higher atomic number, and therefore fluorine is priority number 1 on this side, and OH will be priority number 2. Now let's do the right side of the blue line. So comparing nitrogen and oxygen, we always see that oxygen has a higher atomic number, so this is going to be priority number 1, and priority number 2 will go to nitrogen. Yellow line to see whether the priority number 1s lie on the same or opposite sides. And if we look at this, priority number 1 is on this side, and priority number 1 of the other one is also on this side. So given that the priority number 1s are on the same side, this is going to have a Z configuration. Now let's do some other problems. Whenever you are asked one of these questions, you're going to want to divide your double bond as such. So draw a line that's perpendicular to the double bond, and then start assigning priorities. So let's do this side first. Okay, so we're comparing a methyl with an ethyl. Ethyl takes priority, so that's going to be number 1, and number 2 is going to be the methyl. Now let's see this other side. Over here we have an implied hydrogen. Now we're comparing an ethyl versus a hydrogen. Ethyl is going to take priority, number 1, and hydrogen will be priority number 2 on this side. Now we will draw a dotted yellow line and see whether the priorities of number 1 lie on the same or opposite sides of that yellow line. All right, so number 1 priorities lie on opposite sides of the yellow line, and so this is going to be an E configuration. Now let's do the molecule on the right. We'll split this with a line that's perpendicular to the double bond, and then we're going to decide priorities. On the left, we have iodine versus bromine. Iodine gets priority number 1 because it's heavier, and bromine gets priority number 2. Now for the other side, I'll draw the implied hydrogen, and here we're comparing bromine with hydrogen. Bromine clearly is priority number 1, and hydrogen will take priority number 2. Next, we'll draw the yellow line and see where the priorities number 1 lie. These are going to lie on opposite sides of the yellow line, and so this is going to be a E configuration. Pause the video to see if you can find the E and Z configuration of these alkenes. Alright, so again, we're going to split this double bond with a vertical line, then we're going to assign priorities on each side. Chlorine versus fluorine. Chlorine gets priority number 1, fluorine gets priority number 2. Next side, bromine versus fluorine. bromine will get priority number 1, fluorine will get priority number 2. Next, we'll draw a yellow line and circle our priority number 1s. The groups with priority number 1 lie on the same side of the yellow line, and thus this alkene will have a Z configuration. Over here on the right, we're going to split this double bond, and we're going to decide priorities. On the left here, we're going to compare first a CH2 with a CH2. Those tie, so we move on. Then we're comparing a C with its Cl. Cl is number 1. This is going to be group number 2 up here. Next side, we're going to compare a carbon attached to 2 hydrogens, and we're going to compare that with this one up here is going to be priority number 1, and this one down here is going to be priority number 2. We'll draw in our yellow line and circle our priority number 1 groups. These lie on the opposite sides of the yellow line, and so this will be an E configuration. Now, what is the configuration of these alkenes? Right, so on the one on the left, we're going to split this double bond with a perpendicular line to that double bond, and then we're going to decide priorities. So I'm going to draw in the implied hydrogen that's right here. Okay, and so on this side of the double bond, we have priority number 1 as the methyl, and priority number 2 will be the hydrogen. Then on this side over here, we have a CH3 compared to a C with a bromine and another carbon attached. So this one is going to be priority number 1 down here, and priority number 2 will be up here. Now if we go ahead and circle our priority number 1s, we see that they are going to lie on opposite sides of this yellow line that is always parallel to the double bond. And so opposite sides means that we have an E configuration. The molecule on the right, will split it again, and we're going to decide on the left that ethyl has a higher priority than the methyl over here. And then on the right side, we know that this carbon here has a higher priority than this carbon down here, because down here we have a CH2 compared with a C attached to 2 carbons and a hydrogen. If we circle where our priority number 1s lie, they lie on the same side of the yellow line, and so this will be a Z configuration. Now, how will you assign Z and E configurations of ring structures? Turns out you're going to use much the same process. First, you're going to split the double bond with a blue line that's perpendicular to that double bond, and then you're going to decide priorities on each side. So I'll draw in the implied hydrogen over here, right? And on the bottom side of this double bond, we have a chlorine versus a carbon. Chlorine wins. That will be priority number 1, and priority number 2 will go over here. Next, we're going to compare a carbon here with a hydrogen. Carbon wins, so this will be priority number 1. Hydrogen will be priority number 2. Next, we're going to draw a yellow line that's parallel to the double bond, and we're going to go ahead and circle our priority number 1s. The groups with priority number 1 lie on opposite sides of the yellow line, and so this will be an E configuration of this alkene. Right, now let's do another one. We'll split it again. I'll draw in the implied hydrogens here. Now, on the bottom part, we have a carbon versus a hydrogen. Carbon wins, so that's priority number 1. Hydrogen will be priority number 2. Now, for the top part, we're comparing a hydrogen versus a carbon. Hydrogen is going to be priority number 2. Carbon will be priority number 1. And we're going to circle our priority number 1s, and those are on the same side of the yellow line, and so this is going to be a Z alkene. Now, let's try this on a slightly larger molecule. What is the E and Z configuration of this molecule? So which double bond should you use? Well, it turns out you're going to be using this double bond because this double bond is between 2 carbons. All right, then you're going to assign the priorities as usual. So on the left side, or the bottom left side, we're going to have chlorine versus carbon. Chlorine wins, so this will be priority number 1, and carbon over here will be priority number 2. Okay, then over here we have a hydrogen compared to a triple bonded carbon. Triple bonded carbon is going to be priority number 1, and hydrogen will be priority number 2. We'll go ahead and draw our line that's parallel to the double bond and circle our priority number 1s. These are on the same side of the yellow line, and so this is going to have a Z configuration. Now, what is the E and Z configuration of this alkene? Once again, you will take your double bond and split it down the middle. Over here on the left, up here we have a CH2 combined with an S. Down here we have a C bonded to an O, an F, and an H. Now let's start comparing the biggest atoms first, okay? And so sulfur is heavier than any of these atoms, and so this side up here will be our priority number 1. Down here we'll have priority number 2. Over here on the right side we have a CH2 bonded to another carbon, And down here, we have a C bonded to an H and 2 other carbons. Comparing these two groups, the bottom part of this will be priority number 1, and the top part will be priority number 2. Okay, so let's go ahead and draw in our yellow line. And if we circle our priority number 1s, we see that they lie on opposite sides of the yellow line, and so this is going to be an E alkene. This one is a combination of some linear parts and a ring part. Again, we're going to split the double bond perpendicularly, and then we're going to assign priorities. Over here on the left, we are met with a tie with CH2, so we need to move on. That means we're going to next compare an O with an H compared to an O with a C. So O's are the same, they tie. Now we're comparing a hydrogen and a carbon. Down here is going to be priority number 1, because carbon wins, and up here is going to be priority number 2. Now over here on the right, we see a carbon attached to a hydrogen and 2 carbons. And up here, this carbon is attached to a hydrogen and 2 carbons. Okay, so all that ties out, so we need to move on. So if we move to the end, so I'll circle it in green, we're at this point here, and we're at this point over here. Now we're comparing a CH2C, all right? And down here, we're comparing a CH3. Okay, so up here is going to be winning, that'll be priority number 1, and down here will be priority number 2. We will circle priority number 1 groups, and we will see that they lie on opposite sides of the double bond, and so this will be an E alkene. Alright, so that's it for this video. Now here are 2 extra examples that you can try on your own and write your answer in the comments. If you're interested in online tutoring, would like to buy my book, or would like to visit my website for free resources, feel free to check out the links in the description box below. Thank you so much for watching, and I will see you next time.